So talking about triangles, which is sort of one of the most important figures um, that we use in everyday life. A lot of what we build is based on triangles. So knowing how to find angles and measure and lengths and triangles is extremely important in um, engineering and architecture. Definitely have applications in those areas. So we're basically going to talk about all things triangles in this lesson. And like I said, beginning is kind of review. This goes back, this is probably stuff that you would have done in middle school. Anyway, so we know a triangle, it's polygon, it's got three sides, it's got three corners or points, or what we call vertices, where the angles are, therefore it has three angles. Okay? And how we normally label a triangle is on the vertices, representing the angles, we use capital letters. And for the sides, we use lowercase letters that correspond to the opposite angle. So if you look at this triangle here, if this angle here is uppercase T, and if I draw an arrow to its opposite side, I call it lowercase t. And then you see the same thing was done with W and V. That's normally how we label. Triangle types. And we have different names for them depending on the number, or sorry, depending on the side lengths and even depending on angle measures. Scalene triangle. Do we remember what a scalene triangle is? All the sides are different. All the sides are different. Okay. Another thing with triangles is you can always find the smallest and largest ones by looking at either their angles. Like if you're given their angles, you'll be able to find the smallest sides. If you're given their sides, you'll be able to find the smallest angles. Like the smallest angle in any triangle is always opposite the smallest side. So like if I gave you something like this, 4, 5, 7, okay, we would say, okay, this is the smallest angle because it's opposite the smallest side. What angle is opposite the largest side? That one. So that's going to be the largest. Or we could have done it like this. These aren't to scale, by the way. And I could have done 50, 70, and 60. And I could ask you, okay, which one's the smallest side? Well, the smallest side would be opposite the smallest angle, so it would be this one. This would be the smallest. The largest angle would be opposite the largest, sorry, the largest side, longest side would be opposite the largest angle, which would be this one. Just something additional to that. Isosceles triangle, two sides are the same. And if two sides are the same, two angles are the same. So in this one, this diagram, we can see that this is isosceles because side B is equal to side C. But additionally, the angles opposite those sides, so angle B and angle C, because the sides are equal, their opposite angles must be equal. And finally, a triangle where all the sides are the same, equilateral. Lateral means side, equal sides. And if they have equal sides, so they also have equal angles. So in this one, side A equals side B equals side C, which means angle A equals angle B, which equals angle C. So another word we can use for an equilateral triangle is an equiangular, okay? Because the angles are all the same too. What would the angle measures be of an equilateral? What do they have to be? They have to add up to 180, so therefore each one must be 60. The 60 plus 60 plus 60 is 180. They have to be 60. Okay. We also have right triangles, where one of the angles is going to be a right angle, and that's where the vertical and horizontal sides meet. And of course, that little half box is what we use to represent 90 degrees or right angle. In a right triangle, the side that's opposite the right angle, because it's going to be the biggest side, or the biggest angle. You can't have an angle bigger, or sorry, you can have an angle bigger than 90 degrees. But if you have a 90-degree angle in a right triangle, that has to be the biggest. These two are going to be always smaller. So that means the side opposite is always going to be the longest side. And of course, we refer to that side as the hypotenuse. And then the names of these sides depending on the math that we're using. If we're using Pythagoras, a squared plus b squared equals c squared, we call these sides the legs. If we're using trig, we call these sides opposite and adjacent, depending on what angle we're talking about here, but we'll get to that later in this list. And that's for view as well. Okay, so just to sort of reinforce this with some examples, you are asked to look at each of the triangles, and you're given sides or angles or sides and angles, and you're asked to name them as scaling, isosceles, or equilateral. What would the first one be? Scaling. All sides of it. B. Isosceles. Because two sides are the same. How about C? Isosceles again. Because if two of the angles are the same, that means their opposite sides must be the same. So it's isosceles. D, equilateral. Now E, you might have to do a little calculating here, because we know two of the angles and the angles are different. The question is, what's the measure of this angle? Because if it's 70 degrees or 40 degrees, then it's isosceles. If it's different from 70 or 40, then all the sides are different and it's scaling. So if you find this angle by doing 180 minus 70 minus 40, you should get 70 degrees. Which tells us that the angle is, or sorry, the triangle is isosceles. F is actually similar. Remember, we know it's a right triangle, but we're asked, is it scaling, isosceles, or equilateral? Well, we know two of the angles. So wouldn't it become a question much like E? What would be the third angle? This one here. We know this is 90. We know this is 65, which means we can find this one. This one is going to be 180 minus 90 minus 65. 25 degrees. That means all the angles are different. That means all the sides are different. That means it's scaling. It is a right triangle, but it is also scaled. Okay, another example. You're given a triangle. So you have to figure out what kind of triangle it is. And then if you know what kind of triangle it is, you should be able to figure out all the missing pieces of information you're asked for. So the first one is angle A. Maybe before we find angle A, we'll find angle B. What is the measure of angle B? 63, because the two opposite sides are equal, which means those two angles must be. So we got that. Which means now we can get A. By just doing 180 minus 63 minus 63, or 180 minus 2 times 63. And that will give us 54 degrees. And finally, angle C, we don't actually have to do any math calculating. You just have to figure out, okay, which of these three sides is little c. Isn't it opposite angle C? So here's angle C. Draw an arrow to the side opposite, and that's going to be little c. So little c is going to be 4. Second one, given looks close to a right triangle, but not quite. Okay, so that suggests that, well, unless this is 47 degrees, it's probably going to be scaling. If this is 47 degrees, it's going to be isosceles. But first thing we're asked is to find the measure of angle B. Well, if we know two of the angles, we just find the missing one by doing 180 minus the two angles we know. And we get 40. Do you get 47? Okay, so that tells us that it's isosceles. Which is going to help us find little c especially. What's little b? 7. Because it's opposite angle B, and so it's given there. And because we know it's isosceles, what's little c going to be? 7 as well. Because if this is 47, the sides opposite automatically become equal. Well, I asked you this one earlier. What's the measure of each angle in an equilateral? Well, we just do all three add up to 180. Since they're all the same, we just divide 180 by 3 and we get 60. Next, remember regular and irregular. You should be familiar with. Regular means all the sides are the same. Irregular means they're not all the same. So an equilateral triangle, would that be regular or irregular? regular. All sides the same. Isosceles, irregular. Two of the sides are the same, but the third side is different. We've already been using this next property of triangles already. That the sum of any three angles in a triangle is always 180 degrees. So if you know two of them, you can find the third one, but we've already done ones like that. So in example 5, we would simply find the one missing angle by 180 minus one angle we know minus the other angle we know. And that would give us, if I got it, 97. Okay. Focusing on right angle triangles for a little bit. There's really two big things we can do with right triangles to find missing sides or missing angles. That is Pythagoras, where in any right triangle, the two sides that make up the right angle squared added together equals the longest side squared, or a squared plus b squared equals c squared. Where a and b represent the legs or the sides, they're called here. Okay? And c represents the hypotenuse. So we should be familiar with how to do this. Something that you did in middle school, as well as we reviewed in grade 9, and we've done always a little bit of it other grades as well. So the big thing here is just making sure you put in the numbers for the correct letters. Okay. So what would be, when I plug in all of this stuff, 9, 6, and H into the formula, what's it going to look like? Right. H squared, as they call it H.
Shay, I have a question.
Yeah.
What if you put the 9 where the 6 is?
Fine. Yeah, that's fine. Yeah. But the 6 and 9 have to go on the left in this case. If you're given the hypotenuse, that means one of these is going to be. So then 36 plus 81 is going to be H squared. 36 plus 81 is 117, which is H squared. Take the square root. We don't have to worry about doing plus minus square root with this, because we know it's always going to be positive. And we don't have to worry about exact values, like simplifying this radical. Okay, we're more concerned about an approximate answer. So the square root of 117, 10.8. I don't know if we have any units. No, we don't. So we're done. Okay. I'm actually going to stop there because I don't want to load too much, even though the trig is reviewed. There are some additional topics past that I'll talk about tomorrow to finish that. I think what we've done enough now, the different properties, reviewing those different properties, different types of triangles, how to find missing angles and measures using the different types of triangles, how to find missing sides using Pythagoras. That's pretty good for now. Because